Good afternoon, students.
Good afternoon, ma'am.
Can you see the screen?
Yes,
Okay, so what about yesterday's homework? What about the yesterday's homework? Everybody did it?
yes, ma'am.
So we have seen yesterday two methods to solve second order difference equations. Which one we have seen?
Euler-Cauchy difference equation.
Euler-Cauchy type difference equation and method of reduction of order. So with the help of two methods, we can solve the second order difference equation. Now today we will see another method. So before going to next method, let me know whether you understood this. Whether you did this. Today we are going to see generating function method. So everybody know generating function? If un is a sequence, what is the generating function for it? It is an infinite series, summation n is equal to 0 to infinity un x raised to n, right? So with the help of generating function, we have to solve now second order difference equations. So we will directly take example. Solve n plus 2 un plus 2 minus n plus 3 un plus 1 plus 2 times un is equal to 0 when n is equal to 0, 1, 2 and so on. So what is the order of this difference equation?
2.
Yes. So this also can be written as n plus 2 u at n plus 2 minus n plus 3 u at n plus 1 plus 2 times u at n is equal to 0. Okay, another notation. Now we want to solve using generating function. What is generating function? Let a generating function g of x is equal to summation n is equal to 0 to infinity un x raised to n be generating function. So what we will do, what is this is our generating function g of x, infinite series n is equal to 0 to infinity un x raised to n. Now first we will multiply each term in the difference equation by x raised to n and sum as n goes to 0 to infinity. Okay, so This is difference equation. We will give number 1 to this. Multiplying each term in the difference equation in the equation 1 by x raised to n and summing over 0 to infinity. We get what we will get, summation n is equal to 0 to infinity n plus 2. What is there? Un plus 2 x raised to n. I am multiplying each term by x raised to n first, and then I am taking summation from n from 0 to infinity. Is that okay? Minus
Yes,
summation n is equal to 0 to infinity n plus 3 u n plus 1 x raised to n plus 2 times summation n is equal to 0 to infinity u n x raised to n is equal to 0. Now what we will do, we will make change of index in first two summations. Okay, so here un, I want un. Here I am having n plus 2. So what change I want to make here? Here it is n un plus 2. Here it is un plus 1. In third term it is un x raised to n is there, so I no need to change their indices. But in first two terms I need to change the indices. So what should I change here? I want instead of un plus 2, I want here un.
So n is equals to 2 to infinity.
N is equal to 2 to infinity. Now making or change of index in first two summation, we get summation. If I change it to 2 to infinity, what will be changed here? N plus 2 will become, what will it become? N. What un plus 2 will become? Un. And what x raised to n will become? X raised to n minus. Now in second term, I want un instead of un plus 1. So I will start from n is equal to 1 to infinity. So what will be changed here? N plus 2 un x raised to n minus 1 plus 2 times this summation as it is. N is equal to 0 to infinity un x raised to n is equal to 0. Is that okay?
Yes, ma'am.
Now, what is my gx? Gx is n is equal to 0 to infinity un x raised to n. So what will be g dash of x? Since what is gx? Summation n is equal to 0 to infinity un x raised to n. This implies what is g dash of x? u0 x raised to 0 plus u1 x raised to 1 plus u2
Summation here runs from
x
1 to
square
infinity.
u3 x cube and so on. So what will be g dash if I differentiate with respect to x?
First term will be 0.
First term will be 0 because u 0 and x raised to 0 is 1. So constant. It will be 0. What will be here? u 1.
U1.
Okay. And here 2 times u2 x plus 3 times u3 x square and so on. So what will be in the form of summation?
Summation n runs from 1 to infinity.
Summation n from 1 to infinity n times un x raised to n minus 1. Right?
Yes, ma'am.
Yeah. So I will give number 2 to this. So what will be the change? Okay. Now, therefore, equation 2 can be written in the form of gx now. Therefore, equation 2 can be written as, how I can write summation n is equal to 2 to infinity n un x raised to n minus 2 is equal to, I can write as, I will take this, what will be this? You can see 1 by x g dash of x minus u1 I can write. Sum. Equation, instead of equation, wait, I need to, therefore in equation 2, first sum in equation 2 can be written like this. Is that okay? 1 by x, if I divide by 1 by x, what will be here? N un x raised to n minus 2, right? Can you see this?
Yes, ma'am. Yes, ma'am.
What is 1 by x g dash of x minus u1? It is nothing but this term, first term, first sum in equation 2. And second sum in equation 1 can be written as, and second sum in equation 1 can be written as summation. What is second sum? N is equal to 1 to infinity. No? N is equal to 1 to infinity. N plus 2
Un
to n x raised to
x
n
plus
minus 1. I can write this as summation n is equal to 1 to infinity n un x raised to n minus 1 plus 2 times summation n is equal to 1 to infinity un x raised to n minus 1. Okay. So what is n un x raised to n minus 1? That is nothing but my g dash of
G
x.
dash.
That is my g dash of x. And this this I want to write in terms of g of x or g dash of x, whatever. But here un x raised to n minus 1 is there. So how I can write it? I can write it by 2 by x g of x minus u0 I can write un x raised to n, and if I am dividing by x, I am getting here x raised to n minus 1. Okay. G of x is my summation n is equal to 0 to infinity un x raised to n minus u0. If I do, then it will start from n is equal to 1 to infinity un x raised to n minus 1 by x, and 2 times I am multiplying. So here 2. Is that okay?
Yes, ma'am.
So now I will write 2. So first and second term we have already written, and third term is nothing but just 2 times g of x. So now 2 can be written as, using, I will give number as say 3 and 4, and g of x, okay, using 3 and 4, equation 2 can be written as first term is my 1 by x g dash of x minus u1 minus g dash of x minus 2 by x g of x minus u0, and what is last term? 2 times g of x is equal to 0. So finally we have converted that equation in terms of generating function g of x, g dash of x, and so on. Okay, so our differential equation has been converted into differential equation in terms of generating function. Is that okay? So if I simplify, now 1 by x g dash of x minus u1 here minus g dash of x minus 2 by x gx and minus u0 plus 2 times g of x. So this I can write as g dash of x minus 2 times g of x, which is equal to u1 minus 2 times u0 divided by minus x. Can I write like this? Check it. You just simplify this. G dash terms we have collected. And gx. Is that okay?
Yes, ma'am.
Now, this is my just first order differential equation. u1, u0 are constants. So my right hand side is just function of x. Am I right? Right hand side is my function of x, and left hand side is just g dash of x minus 2 times gx. So it is first order ordinary differential equation. Is that okay? So for
Yes.
u1 is equal to 2 times u0. This difference I will give number 5. Equation 5, what it becomes? G dash of x minus 2 times gx is equal to 0. Is it? Un is if u1 is equal to 2 times u0, this will go to 0. Right hand side
Yes.
goes to 0, and my equation 5 will reduce to homogeneous differential equation, and we will get its elementary. What will be its solution then? This implies g of x is equal to, what is the solution of this differential equation? This is not difference equation, this is differential equation. First order ordinary differential equation. What is the solution? E raised to 2x
Yes, ma'am. R is equals to
Raised
2
to
implies E raised
2x.
to.
But what is e raised to 2x? It is nothing but summation n is equal to 0 to infinity 2 raised to n upon n factorial x raised to n 2x raised to n upon n factorial, right? E raised to 2x, I can exponential function, I can write in terms of infinite series, right?
Yes.
So if gx is equal to this one, this implies gx is nothing but my summation n is equal to 0 to infinity un x raised to n and which is nothing but my summation n is equal to 0 to infinity 2 raised to n upon n factorial x raised to n we have got. So this implies what is here I can write that is, and here I can write un. What will be un then? 2 raised to n upon n factorial for n is equal to 0, 1, 2 and so on, right? If gx is this one, what is un? Un x raised to n. So un must be 2 raised to n upon n factorial.
Factorial.
So this is my one solution. But my given difference equation is second order. So I must have two solutions, right? So to find second solution, I will use previous method, reduction of order method. Okay. So which is one solution. So to find another solution, what we will do to find another solution म्हणण्यापेक्षा second solution. To find second solution, what we will use? We use Wronskian. Second solution, we know that Wn plus 1 the Wronskian satisfies 2 upon what is that? Minus 1 square P0
Minus
upon
1 is 2.
n plus 2. Wn, what is P0T? 2 and n plus 2 here, right?
Yes, ma'am.
From question 1, what is P0T? P0 is 2, P2T is n plus. So Wn plus 1 satisfies, or instead of that I will write minus 1 square means it is 1 only, so I am not writing it again. P0T upon P2T Wn, that is 2 upon n plus 2 W of n. So now this is again linear first order difference equation. What is its solution? Which is
W at n is equals to
first order difference equation, and its solution is given by, what is the solution? Wn should be what? Product from s is equal to a to t minus 1. आता इथे n minus 1 पर्यंत. So
W at n is equals to W at 1 into product of s is equals to 0 to n minus 1
n
P at
minus
s
1 p at x
P
is
at
nothing but 2 upon s plus 2, right?
yes,
So
ma'am.
it will be this.
2 raised to n,
Uh,
2 raised to n upon s plus 1 factorial.
n plus 1.
N
N plus 1 factorial. So Wn is nothing but 2 raised to n upon n plus 1 factorial. Therefore, second solution, if one solution is known, then second solution is given by say second solution, say now we have instead first solution we have denoted by un, so second solution say we will say vn is given by, what is second solution is given by vn u2t is nothing but u1t. So here un summation wn divided by un plus 1. That is my solution, right?
Yes, ma'am.
Second solution. And un is 2 raised to n upon n factorial summation. What will be this? What is wn? 2 raised to n upon n plus 1
N plus 1 factorial
divided by un 2 raised to n upon n factorial 2 raised to n plus 1 upon raised to
n factorial divided by 2 raised to n plus 1.
what is remaining?
N factorial divided by 2 raised to n plus 1.
Raised to n factorial as it is summation. What is remaining?
N factorial divided by 2 raised to n plus 1.
Yeah, n factorial divided by n plus n factorial divided by
2
2
raised
raised
to
to
n plus 1.
raised to n plus 1. So if I want to write in terms of, or this is n is equal to 0 to not, instead of write I will write k because it is in terms of n. If it is in terms of t, I have to write k is equal to 0 to t minus 1. So 2 raised to n upon n factorial summation k is equal to 0 to 1 k factorial divided by 2 raised to k plus 1. Okay, that is my second solution. Is that okay? So the general solution, therefore the general solution of equation 1 is, what is that? U
At n,
at n is equal to now c1 times un
C1
is
times
first solution and plus c2 times vn.
Pn.
Here you can say un times the पहिला. So whatever may be, what is that? Raised to n upon n factorial. 2 raised to n upon n factorial I can take common c1 plus
C2 times
summation k is equal
summation k is equals to 0 to n minus 1.
to k factorial divided by 2 raised to
2 raised to
k.
n plus 1.
That is my final required solution. Is that okay?
Yes, ma'am.
This is general solution I am writing. This is our first solution, which we have written like UN only, but you can say it is. can take another example. Use homework you can take. Exercise 3.88, page number 118. Use method of generating functions to solve the difference equation 3 times n plus 2 un plus 2 minus 3n plus 4 un plus 1 plus un is equal to 0 if u0 is equal to 3 times u1. Okay, in previous example u0 is equal to 2 times u1 we have taken. Now here you can and another exercise also from the 3.90. Check that un is equal to 2 raised to n solves n times un plus 2 minus 1 plus 2n un plus 1 plus 2 times un is equal to 0. So what you have to do here? You have to check that un is equal to 2 raised to n is solution. Means just you have to substitute here un is equal to 2 raised to n and check LHS is equal to RHS or not. Okay. And find a second independent solution is given. You have to find another solution by using Wronskian. Just now we have calculated like that. Second independent solution. Is that okay?
Yes, ma'am.
Now we will take another method.
मॅम हे पहिलं जे आपण एक्झाम्पल घेतलंय ना जनरेटिंग फंक्शनचं,
काय का?
हे जनरेटिंग फंक्शन मेथडनं जे एक्झाम्पल घेतलंय ना पहिला, त्यात एक स्टेप नाही कळाली.
ते नाही
त्या
कळालं.
फर्स्ट टर्म साठी लिहिलंय ना, हा इक्वेशन 3 नाही कळालं त्यातलं.
हे का? हे is this? Is this?
मॅम स्क्रीन थोडी लेट दिसते मला.
आता दिसतंय का?
नाही.
नाही.
हा आता दिसलं.
हा. मी येलो केलाय बघा त्याला. ते नाही कळालं का?
हा तर ते नाही कळालं. कारण त्याला जर सॉल्व केलं ना तर ते यायले समेशन n रन्स फ्रॉम 1 to infinity n un x raised to n minus u1 upon x. मग ते मायनस u1 का घेतलं?
u1 इथे मला फर्स्ट टर्म नाही पाहिजे ना. n is running from 2 to n ना.
मग u0 पण मायनस करायला पाहिजे होतं ना तिथं आपण.
u0 कुठे येते? This is running from 1 to infinity. याला सिम्प्लिफाय करा ना तुम्ही. Let me
केलं
read नाही करते. If I simplify this, what is this? u1 x x raised to 0 म्हणजे u1 फक्त ना.
हा
u1 n
येस मॅम.
आणि तुम्ही याला n is equal to times x म्हणजे 1 just 1 right times u
u2
times u plus n is equal to 3 times 3x plus 4 times u4 x square and okay.
येस मॅम.
आता मी याला काय केलंय 2 times u पाहिजे मला u1 नको आहे मला g dash मध्ये u1 नको आहे because my here this summation starts from 2 times u2 ने start होते ओके इथून start होते
हां.
is that okay
येस मॅम.
here so I don't want u1 so first I have subtracted u1 from g dash of x इथून मी u1 subtract केला आता हे नाही आहे आता काय राहिला 2 times u2x plus 3 times u3x square and so on but I want here only 2 times u2 2 times u2 तर मैं x ने divide केलं 1 by x each term I am dividing by 1 by x
1 by
so 3 times u3 इथे x square होता तर x झालं 4 times u4 x इथे x cube येईल ना
हो.
ही टर्म आणि मला x स्क्वेअर पाहिजे तर मी x ने प्रत्येक टर्मला डिवाइड केलं तर मला हे सेम मिळेल इज दॅट ओके
येस मॅम.
नाउ नो प्रॉब्लेम सिमिलरली 4 याच्यामध्ये पण gx मायनस u0 केलं तर आणि 2 by x केलं तर मला ती मिळेल ही टर्म मिळेल इज दॅट ओके
येस मॅम.
shall I go further
येस मॅम.
so now another method is factorial series method so here you have to use or you have to substitute in this method you have to substitute ut is equal to summation k is equal to 0 to infinity in the form of factorial a k t raised to k falling minus k falling okay so if I want to find solution by factorial series method we have to use this substitution we will see how it works while solving examples find a factorial series solution of the difference equation 2 times u at t plus 2 plus t plus 2 t plus 1 u at t plus 1 minus t plus 2 t plus 1 u at t is equal to 0 or this also can be written as 2 times u at t plus 2 plus t plus 2 delta t plus 1 delta u at t either this or this you can just simplify this delta u at t What will be this? U at t plus 1 minus u at t. So this I can write in the form of delta. Okay. So I want to find factorial series solution, means first I have to use here this substitution. Note that factorial series solution need not always exist for every second order difference equation. So wherever it exists, then only we can use it. Otherwise, we cannot use this method. So substituting ut is equal to summation k is equal to 0 to infinity. What is that? Ak t raised to minus k falling. In equation 1, what I will get at the equation 1 I will this equation 1 we will say. So if I substitute, what I will get? Summation, substituting ut in equation 1. We get, what we will get? Summation k is equal to 0 to infinity 2 times ak. What will be here? T plus 2 raised to minus k falling plus t plus 2 t plus 1. What is delta of summation k is equal to 0 to infinity ak t raised to minus k falling? Zero term as it is, t plus 2 k falling plus t plus 2 t plus 1. What is delta of this? Delta is linear, so I can take inside summation ak outside delta t to the minus k falling. What is delta t to the minus k falling?
T plus 1 minus
Not t plus
times
minus
minus
k t to the minus k minus 1
minus
falling,
k.
right?
Yes, ma'am.
Now, since t plus 2 t plus 1 t to the minus k minus 1 falling is nothing but t plus 2 minus k plus 1 falling. Am I right? Am I right? If you simplify t plus 2 to the minus k plus 1 falling, 2 times you decrease it, so t plus 1 t to the minus k minus 1 falling. Is that okay? Minus
Yes,
2
ma'am.
correct?
Yeah.
So we have implies, I can write summation k is equal to 0 to infinity 2 times ak t plus t plus 2 to the minus k falling plus summation k is equal to 1 to infinity ak minus k t plus 2 to the minus k plus 1 falling, which is equal to 0. Can I write like this? This I am writing as this term. Is this okay?
Yes, ma'am.
Summation k is equal to 1 to infinity ak minus k t plus 2 minus k plus 1. So one second. Hello. हाँ हाँ एक्नॉलेजमेंट कहाँ पे? हाँ हाँ उस पे लेना पड़ेगा. हाँ हाँ उधर भी डायरेक्ट सर को साइन लेना पड़ेगा. हाँ ठीक है. हाँ तो लेके आना पड़ेगा ना. सर नहीं आए ना अभी तक. ठीक है. आप खाना खा के देते ना. So, so what? So now you can see here. Summation k is equal to 0 to infinity. So I want here instead of k, I want here k is equal to 0 to infinity. So making change of index, in second term as k going to k plus 1, we get summation k is equal to 0 to infinity 2 times ak minus k plus 1 t plus 2 to the minus k falling, which is equal to 0. Is that okay? In second sum, here instead of k is equal to 1, I want k is equal to 0 to infinity. So I am making changes index as k to k plus 1. So here ak plus 1 minus k plus 1 will be there. Remaining will be as it is. Is that okay?
Yes, ma'am.
So some problem in pen. then A0 is arbitrary and we will get AK plus 1 is equal to 2 upon K plus 1 AK. This must be 0, right? For K greater equal to 0. Is that okay? This whole summation is equal to 0. So this implies 2 times AK minus K plus 1, AK plus 1 must be 0. So AK plus 1 is equal to 2 upon K plus 1 AK. And again this is first order difference equation, which is first order difference equation, and its solution is given by what is solution? AK is equal to 2. So 2 will be repeated K times, right?
AK is equals to
2 upon K plus
2
1 na.
divided
So
by
this
K
term
minus
will be repeated
K factorial.
K times. So
K factorial.
K factorial times A0, right? A at 0. I can take as 1 also, A0. So we got AK, therefore factorial series solution is given by ut is nothing but A0 summation K is equal to 0 to infinity AK. AK is my 2 raised to K upon K factorial T to the minus K falling. That is my factorial series solution. And this solution converges for all T except the negative integers. Is that okay? This is the solution. Is that okay? So in generating function, you have to substitute summation. If you, in terms of n, then g of x you have to take a generating function as summation n is equal to 0 to infinity un x raised to n. And in factorial series method, you have to substitute ut is equal to summation k is equal to 0 to infinity ak t to the minus k falling, and you have to find here ak. In above method, we are finding un coefficient. Here we are finding AK coefficient. Is that okay? So whenever it is told you have to find a factorial series solution, use this substitution. You have to remember this. And whenever it is told that using generating function method find the solution, then you have to use gx is equal to summation n is equal to 0 to infinity un x raised to n as substitution. And to differential equation. Is that okay? Again, one exercise you can take here. .94, page number 119. Shall I write down that, or you have already that PDF file already I have shared, right?
Yes, ma'am.
So you can directly do from that.
Okay, ma'am.
Exercise 3.94, page number 119. Find the factorial series solution of the form for the equation. Okay, so this will complete our linear difference equations. And only last section of this unit is remaining now, non-linear equations that can be linearized. So is that okay?
Yes,
In
sir.
second unit now only three methods, 2 or 3 methods are remaining. So in 2 or 3 lectures we are going to complete second unit. So 3.6 is remaining only, non-linear equations that can be linearized. Up to now we have seen how to solve linear equations. Now we have to see how to solve non-linear equations.